Talk about an interesting second order section and second order structure, and this is going to be a high pass circuit, but I want to talk about it because it's also got kind of an interesting core in the middle. So this is the core circuit, and for values we're going to use these 5 sets of values as we build through it. In terms of R, R1, R2, quite a difference between what R1 and R2 is, and that's actually going to come through as we work through this. C is 1 nanofarad, and C1 is 2.5 nanofarads. And we'll sort of see what some of the thinking is. What's interesting is everything that's in this green area is a form of a gyrator. Now, it's maybe not sort of the perfect Corda model, but it has the sense of a gyrator that it basically says, let me take this capacitive element, and effectively it's going to effectively make the circuit with the op-amp and the resistors to look like an inductive element. And so in the end, that's what we're going to get. And in fact, we'll get a case where it'll look like R1 and this inductance that's related to a product of R1, R2, and C. Okay, how do we get there? Well, you start off by taking this element. You realize that I need to figure out for V1, I need a particular current. Well, there's 2 different currents in there that I would work with. One is I1, which is going through this resistor, which goes to VA. Now, this is an ideal op-amp, so that term voltage will also be VA. Excellent. I2 is then the current through the capacitor, which is then just volt V1 and VA. Notice you get the difference of V1 and minus VA in both cases. That will turn out to be useful because then I can sort of sum this. I'm going to be able to group those together and do a little bit of math. I get 1 over R, R1 here, 1 plus S, R1C, and that gets me fairly close to what I'm looking for. Interesting enough, I still have to deal with VA. Now, how do I pull that out? Well, I can solve for VA. That the way I can get to that is also realizing I've got a voltage divider between V1 and VA. This gives me a voltage divider. Now, granted, this is an R and a C. It's a high-pass filter, effectively. It's a first-order high-pass. So that's why I'm going to get the S R2C and the S R2C in those terms. So I get a 1 minus this, which, funny enough, 1 minus a high-pass gives you a low-pass. And that seems to be the mindset that's happening here. And so that turns out to just give me the 1 plus SR2C. It allows me to put that underneath here. Why is that relevant? Because that's at least going to have some effect of the dynamics, but I can push that corner far out. Push it far enough out that I can actually make everything be set by much more the R1C term in this entire structure. And so as a result, it's 1 over that. And it's then mostly going to be the term here, because if this corner is like, fairly low frequency, this is fairly high frequency, I can now start to say, well, what would happen? And so if R2C is actually fairly large, then what I'm going to be able to do is move that corner frequency out quite a bit. And as a result, I can kind of solve this problem such that, okay, I can just have effectively this sort of equivalent resistance structure, which is kind of nice. And if I think about it resistance-wise, it's going to be roughly about 100 ohms here, and then eventually turn up and increase at basically the inductive element. And this is what's going to give me my inductive structure as I work through this. Well, the nice thing is once I have an inductive element, I can then build on it and put all of this together here. And then this looks like a capacitor, resistor, and inductor circuit. Pull these together. It allows me to do that. I chose R1, choosing R being much greater than R1. It's sort of much greater. We'll kind of go through this in the math. This will be 625 ohms. That kind of gives me a Q of 1. The net result of that, with a center frequency of 1 kilohertz, that ohms gives me about a Q of 1. Gives me a nice high-pass filter, second-order structure there, and then converges back to 1 when I finish out the structure.